Today we're going to review Module 2. We're going to begin at Lesson 2.1, which is graphing numbers and comparing numbers. We all see that we have a number line where we have our negative integers on the left-hand side and our positive integers on the right-hand side. When we have to identify the position of the integers on a line, we can show by a dot. If we have, let's say, fractions or signed decimals on the line, we can also use an arrow to indicate that this would be 4.5 or 4.5. And then for comparing numbers, we saw in this module that we needed to use greater than, less than symbols. And remember, when you think about money, it makes comparing numbers quite simple. You ask yourself, which one would I rather have? And that's where the open side of your greater than, less than symbols are facing. So if we have -4 compared to 0, we see that 0 is greater, because if you were talking about money, it'd be much better to have $0 than -4. In this review, you will practice many different questions, so you'll need a piece of paper and you're going to pause the video, try the questions, and then you can watch the solution. So we'll go through the module that way. So for number 1A, we're graphing numbers on a line, and we're simply going to be placing the number either by dot or positioning using an arrow. So the first number is -5, so we can see that's here. 1.5, which is positive, that's halfway between 1 and 2. 7/2, if we change that to a mixed number, 2 goes into 7 3 times with 1 left over, we can see that it would be in the position halfway between 3 and 4. So 7/2 will go there. -1 is on the negative side of our number line. And then +3. For B, we're using the greater than, less than symbol. We're comparing -9 and -15. Which one would you rather have in your bank account? -9 is closer to 0. It's the greater integer. Then we learned how to add integers. We learned the integer rules for adding, which tell us that if the signs are the same, we just add our integers and keep the sign. So for example, if we're adding two negative numbers, -9 plus -2, the result will stay negative. Conversely, if we add a +9 plus a +2, the answer will stay positive. But when the signs are different, we're going to subtract and keep the sign of the larger number. And when I say larger number, I mean the larger absolute value. So -5 plus 3 means that we're going to keep the negative sign and we're going to subtract 5 minus 3 because 5 is the greater absolute value. So we will end up with a -2 answer. Number 2 practice, you're going to practice adding using the adding integers rules. So 2A, we're adding two negative numbers. -5 plus -11 means that I'm going to keep the negative sign, they're the same, and I'm going to just add the integers, -16. For B, both my integers are positive, so I'm going to keep the sign, they're both positive, so the answer will be positive. 6 plus 9 is 15. For C, the signs are different. When the signs are different, we're going to keep the sign of the greater number, which is 8, and that's a positive integer, and then we're going to subtract. 8 minus 4 is 4, so my answer will be a +4. For D, we have a negative plus a positive. Again, we're going to keep the sign of the greater number, which is 12, and we'll subtract 12 minus 7, which is 5. So the answer here is -5. For E, when you have a chain of all different integers, what you can do to make life easy is to combine the ones that are the same, or what we call like terms. So we have negative integers. Let's put those together first. Negative 9 plus negative 2 is negative 11, plus negative 3 is negative 14. And then we can combine our positives. 5 and 7 makes positive 12. Now that the signs are different, we can compare, but 14 is the greater number, so we're going to keep the negative sign and we'll subtract 14 minus 12, which is 2. So the final result is negative 2 for E. The rule for subtraction of integers is what we call add the opposite. So what this means is we take all subtractions and change them into additions, but in order to do this, it means we have to change our next integer into its opposite. So we're going to change all subtraction problems to addition problems. We're going to keep our first integer the same. We'll change to adding, and our second integer will change to its opposite, meaning if it's a positive integer, it'll become negative, or if it's negative, it'll become positive. So for example, when we have a negative 9 minus a negative 8, in order to see this more clearly, we're going to change the subtraction to adding and change our negative 8 to a positive 8. So we're making 2 pencil strokes here. Now we can see this as negative 9 plus a positive 8. We can use the adding integers rules now that state that the sign of the greater number is 9 here, so that will be negative. That is kept, and then we subtract 9 minus 8, which is 1. So our answer here will become negative 1. So now you can try the subtraction. Remember to add the opposite and follow your addition rules. For 3a, we have negative 5 minus negative 11. I'm going to add the opposite, which changes this to negative 5 plus a positive 11. The greater sign is the positive. 11 is greater absolute value than 5. And we're going to subtract 11 minus 5, which is 6. So we'll have a positive 6 result. For b, we have 6 minus 9. I'm going to change subtraction to adding and change the positive 9 to a negative 9. 6 plus negative 9 means that this answer will be negative, and 9 minus 6 is 3. So our result will be negative 3. For C, we have negative 4 minus 8. We're going to get rid of this minus sign, change it to adding, and the 8, which was positive, becomes negative. Now we have two integers with the same sign. Negative 4 plus negative 8 means that I keep the sign and add the integers. 4 plus 8 is 12. So our answer is negative 12. For D, we have negative 12 minus 7. We are going to add, and then the positive 7 becomes negative 7. And again, we're going to be adding like-signed integers. Negative 12 plus negative 7 results in negative 19. For E, we have a longer grouping of numbers. Let's get rid of all of our subtractions and make them addition first, changing the second integer to its opposite. So here we have subtraction. Let's change it to adding, and the negative 2 becomes a positive 2. Here we have negative 3 minus 7, so we're going to change this to adding, and the 7 becomes a negative 7. Now we can combine our like terms. Let's put all the negatives together. 9 is negative, 3 is negative, and 7 is now negative. Negative 3 plus negative 7 is negative 10. Plus negative 9 is a negative 19. I can also combine my positives with each other. 5 and 2 are positive, so I'm going to be adding positive 7. Now we can see the signs are different. We're going to keep the sign of the 19 and subtract 19 minus 7, which is 12. So our result here is going to be a negative 12. For lessons 4 and 5, we looked at multiplying and dividing integers. So we have rules for multiplying and dividing, and these rules are pretty straightforward. If the signs are the same, whether we're multiplying or dividing, if we have same sign, our answer will be positive. If our signs are different, our answer will be negative. So for example, negative 9 times negative 8, we have the same sign, so our answer will be positive, and 9 times 8 is 72. For our second example, we have negative 15 divided by 5. This time we have a negative divided by a positive, so because the signs are different, the answer will be negative. And 15 divided by 5 is 3, so will result in negative 3. So now you can practice multiplying or dividing using those rules for integers. For A, we have negative 5 times 11. So we have a negative times a positive, our result will be negative, and 5 times 11 is 55, negative 55. For B, we have a positive divided by a positive. 16 divided by 2 means our result is going to be positive, positive 8. Same sign, positive answer. C, we also have the same sign. They're both negative signs. Negative 4 times negative 8 results in a positive answer. Negative 4 times 8 times negative 8 gives a positive 32. For D, we also have negative times negative, which results in a positive answer. Same sign, positive answer. 10 times 7 is 70. And for E, we're dividing. Negative 49 divided by positive 7. The signs are different, so we'll have a negative answer. 49 divided by 7 is 7. So our result is negative 7. For lesson 6, we looked at exponents and square roots. Exponents means repeated multiplication of that number. So for example, a negative 9 squared means negative 9 times negative 9. You can use epon for negative numbers, it's very handy. If you have an even number of negatives, the answer is positive. If you have an odd number of negatives, the answer is negative. The opposite of exponents are square roots. So when we know that 8 times 8 makes 64, then we understand that the square root of 64 is equal to 8. So whenever we see the square root symbol, we have to be thinking, okay, what times itself makes that number? So now we're going to solve exponents or square roots. For A, you have a half to the power of 2. And this means a half times a half. And we know with fractions, when multiplying, we just multiply numerator times numerator, denominator times denominator. For B, you have negative 1 cubed. This is negative 1 times negative 1 times negative 1. We know that 1 times 1 times 1 is equal to 1. But now we have to determine if this answer is going to be negative or positive. We see that we have 3, or an odd number of negatives. And when we look at epon, odd number of negatives results in a negative answer. So our answer here is going to be negative 1. Alternatively, you can work it out step by step. Negative 1 times negative 1 results in a positive 1. Times negative 1 will give you that same answer. It's possible for small exponents like this to do it that way, but when we get to larger exponents, epon really is very helpful. For C, we have the square root of 36. So we ask ourselves, what times itself makes 36? And we know that 6 times 6 makes 36. So the square root of 36 is 6. 2 to the power of 4 means 2 times 2 times 2 times 2, and these are all positive, so we know our answer will be positive. 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the power of 4 is 16. For E, we have the square root of 49, but notice that this negative sign is outside the square root. That means that that needs to be held for our answer. It's like a negative sign outside of a bracket. So the square root of 49, what times itself makes 49? Well, that's 7. So we're going to hold the negative sign, and the square root of 49 is 7, divided by a positive 7. So we have negative 7 divided by positive 7. Our answer will be negative, and 7 divided by 7 is 1. In lesson 7, we learned about sign decimals. We have the same sign rules as the integers. So adding and subtracting, multiplying and dividing, we follow those sign rules. We learned that we have some ways that we can make decimal multiplication easier, which is counting the decimal places for both the numbers that you're multiplying, and then taking that number of decimals for your answer. And we also learned decimal division to move the decimal out of the divisor. And if we move the decimal, for example, 1 decimal place in the divisor, we have to move the same number of decimal places in our dividend. So take a look at 7a and b. We have multiplication and division of decimals. For 7a, we have 4.42 times 2.3. These are both positive numbers. So we're going to see that we have 3 decimal places in total, and our answer will be positive. What we can do now is drop the decimal and begin to multiply as though there's no decimal there. 3 times 2 is 6, 3 times 4 is 12, 3 times 4 is 12 again, and 1 more makes 13. In our second row, we must remember to place a 0. 2 times 2 is 4, 2 times 4 is 8, and 2 times 4 is 8. We add up our rows, 6, 6, 11, and 10. And we know that we need to move 3 decimal places from the right. So our decimal will be here. Our answer is 10.166. Now if we had a sign here in front, for example, if we had a negative 4.42 times 2.3, our answer would be negative. If they were both negative, our answer would be back to positive. So when we're multiplying, same signs, positive, different signs, negative. And the same thing goes with division. Here we happen to have 2 positive decimals, so our answer will be positive, and we can set up the long division. 3.2 is the divisor, 14.4 is the dividend, but we need to move the decimal place out of the divisor and therefore move the decimal on the dividend as well. So we're going to put that decimal place above, and then we'll look at it as though there's no decimal at all. 32 goes into 144 4 times. 4 times 32 is 128, and we'll subtract that, leaving us with 16. We add a 0 in because our goal is to get to a 0 remainder. And 32 goes into 160 5 times evenly. 5 times 32 is 160. So our result is a positive 4.5. But again, remember, if you had 14.4 divided by negative 3.2, If the signs are different, then your result would be negative. For lessons 8 and 9, we learned about adding and subtracting sign fractions and multiplying and dividing sign fractions. We follow the same adding and subtracting sign rules as integers, with a little bit of a twist, in the sense that we need to change to our lowest common denominator as we learned with positive fractions, but with mixed numbers, we're going to change to improper fractions. We're going to avoid borrowing or carrying whenever possible when we have negative signs. So for example, we have 1/4 minus 1/3. These are both positive fractions, so we can do them the same as we've always done. We're going to find our lowest common denominator, which is 12, and we're going to change the fractions to have like denominators. So this will be 3/12 minus 4/12. We see that 3 minus 4 is going to take us into the negative side. So in order to see things more clearly, we can get rid of this minus sign, change it to a plus sign, and make the positive 4/12 into a negative 4/12. We know with adding and subtracting, we keep our denominator, and 3 plus negative 4 results in a negative 1 because we keep the sign of the greater number and subtract. So negative 1/12 is our answer here. So let's take a look and solve these two questions using the rules for lowest common denominator and our sign rules. For A, we have 14 and 7, so we need to make them like fractions by multiplying our second fraction by 2. Negative 13/14 plus a negative 4/14 means that the signs are the same, so I can keep the sign and just add those numerators. So the denominator stays as 14, and the negative 13 plus negative 4 results in a negative 17. From here I can change to a mixed number. 14 goes into 17 once, and this is going to be a negative 1, and we have 3 remaining out of 14, so a negative 1 3/14. For B, we have the issue of the subtraction, and we have mixed number. So let's worry about the signs first. Let's change the subtraction to adding and change the 3 1/3 to a negative 3 1/3. Now let's make everything into improper fractions. Negative 4/1 plus a negative, 3 times 3 is 9, plus 1 is 10, negative 10/3. The denominators are different, so I will have to multiply my first fraction, giving me negative 12/3 plus a negative 10/3. I have negative plus negative, so I can simply add the numbers, giving me a negative 22/3, and now I can change back to a mixed number. 3 goes into 22 7 times. Remember that we keep the sign, it's a negative 7 with 1 remaining over 3. For lesson 10, where we're multiplying and dividing sign fractions, we're going to follow the same sign rules as integers, and we're going to follow the same fraction rules that we learned in Module 1. So we're going to change to improper fractions. This time we're not going to change to our lowest common denominator. Whoops. We don't need that for multiplying and dividing, but we do need to cross reduce for multiplication, and we do need to keep change and flip. So for example, we have both positive fractions here, so we're going to go ahead and change 2 1/4 to be 9/4 divided by 1/3, and we're going to keep, change, and flip to the reciprocal. Here we have no cross reducing, so we're going to multiply numerator times numerator, which is 27, and denominator times denominator, which is 4, and then we can go ahead and change to a mixed number. 4 goes into 27, 6 times, with 3 remaining over 4. So for the practice for multiplication and division, for the first one, we don't mind that the denominators are different. We don't need to change them. So we're going to look to cross reduce, and we notice that we have a negative times a negative. So our answer is going to be positive, we know that. And then we can solve for these fractions. So we have 14 and 7, so we can divide by 7. And we have 2 and 4, so we can divide by 2. 2 times 1 is 2, and 2 times 1 is 2. So negative times negative is a positive, and 2 over 2 is equal to 1. So our answer here is a positive 1. For B, we have division. So we're going to take that negative 4, place it over 1. We're going to be dividing by improper fraction. 3 times 3 is 9, plus 1 is 10 over 3. And now we're going to keep change and flip. We have a negative 4 over 1 multiplied to 3 over 10. We have a negative times a positive, which means our result will be negative. And we can look to cross reduce, and with 4 and 10, they're both divisible by 2. So we have a negative 2 times 3 is a negative 6. Over 1 times 5 is 5. And we can change this to a mixed number. So our mixed number will be negative. 5 goes into 6 once, with 1 remaining. So negative 1 and 1/5. Lesson 11 was order of operations. We learn a BEDMAS to help us with the order of operations, to know what to do first, second, third, and so on. So A stands for absolute value. B stands for brackets. E stands for exponents and square roots, because they are the inverse of each other. Division and multiplication are in the same position, so if you have them both, you have to work left to right. And the same with addition and subtraction. Adding doesn't come before subtraction. If you have addition and subtraction, you're going to work left to right. So for number 11 practice, we're going to solve these fractions in brackets first. So we have subtraction in brackets and then multiplication by another fraction. So we're going to add the opposite. This is subtraction, so let's make it into adding the opposite. Now luckily our denominators are like denominators, so that's wonderful. So we can just keep the denominator of 4, and then we have a negative 14 plus a negative 2. So this is negative 16 over 4. Now that we've cleared those brackets, our next step is to multiply by a negative 2/5. Now we have to remember that the common denominator is not necessary, and we're going to look to cross reduce. So we do have a 2 and a 4, so we can divide by 2, and then we're ready to multiply. Negative 16 times negative 1 results in a positive 16. And 2 times 5 is 10. So our answer is positive, and we're going to change this to a mixed number in lowest terms. 10 goes into 16 once, with 6 remaining. But 1 6/10 is not in lowest terms. We can divide by 2. So we're going to end up with 1 3/5, and that's a positive 1 3/5. This one, B, looks a bit scary, but it need not be. When we follow BEDMAS and go step by step, we're going to be just fine. So what we hone in on here is the fact that we have 2 sets of brackets. So we're going to solve both sets of brackets. The first set is negative 4 minus 8, so we're going to add the opposite. Negative 4 plus negative 8 results in a negative 12. So this part's done. And then we have another set of brackets here. We have 9 times 2 plus 7. Within the brackets, we have to follow order of operations, which means that we are going to do the 9 times 2 first and then add the 7. So 9 times 2 is 18, plus 7 gives us a result of 25. We're going to keep that in brackets because notice next door this 3 squared is actually going to be multiplied to that whole bracket. There's no symbol between, which means they're touching, so they're going to be multiplied. So we're going to copy everything else down. And I know it looks a little bit wonky, so maybe I'll just write this negative 12. And so that's our new order of operations. Negative 12 divided by 2 plus 3 squared times 25. Well, we've got an exponent now, so let's do that. So I'll write it nicer. Negative 12 divided by 2 plus 3 squared is 3 times 3, which is 9. And now if you prefer, you can write it with a symbol or with a bracket or a raised dot, 9 times 25. Now we have division, adding, and multiplication. We must divide and multiply before we can add. So we can do two things now. We can take negative 12 divided by 2, and we can take 9 times 25 and do them both. So negative 12 divided by 2 is a negative 6 plus 9 times 25. So we might not need to do that over on the side here. 9 times 5 is 45. 9 times 2 is 18. And 4 more is 22. So 9 times 25 is 225. And we have a negative 6 plus 225. So our positive integer is going to come out top. So our answer is going to be positive, and we're just taking 225 minus 6, right? So we're going to end up with 219 as our result of this order of operations question. For word problems, the biggest thing is to read carefully and read more than once. Make a plan in your mind, visualize what's going on in the problem, and then when you're ready to do your calculations, be very careful. Did you write out the numbers correctly? Do you have everything planned out? Check your answer in terms of, does this answer make sense based on the story and the problem that I've been provided with? And finally, when you write your answer, make sure you have units such as money, kilometers, kilograms, and make sure that you have money that has decimals written correctly. So for example, if the answer you got was 14.1, but it's money, you're going to have to add a 0 there to make that $14.10. So it needs to look like money that we use in our everyday life. This word problem says Mr. Rodriguez pays $53.19 each month to household finance. How many months will it take him to pay off $1,436.13? Well, every month is the same, $53.19, $53.19. And his goal or total is to pay off this larger amount, $1,436.13. So here we're going to divide. We're going to divide up that total goal amount by the payments to see how many months we'll be at. So we need to take 53.19 into 1,436.13 because we learned that when we are writing our division sentence, the second number is our divisor and that goes outside. Now we have a problem here with decimals because we have 2 decimal places in our divisor. We need to move those out. So these are big numbers, but we don't need to be scared by big numbers. We just need to take this step by step. So we have 5,319. Going into 1, no. 14, no. 143, no. 1,436 doesn't go. 14,361, that's where we're going to be at. Now 5,000 times 2 is 10,000. And 5,000 times 3 is 15,000. So 15,000 is too much. So we're going to put a 2 up here and then do the work on the side. 5,319 times 2. Let's solve now. 18, 3, 6, and 10. So 5,319 times 2 is 10,638. And you can always erase your decimals to make it look nicer, more clear for yourself. We're going to subtract now. We need to borrow 3, 2, we're going to borrow again, 7, and 3, and now we bring down. And now we're going 5,319 into 37,000. Well, 2 times gave us 10,000. So we're getting to 37,000. 6 times should be around 30,000. Can we squeeze in 7 times? Let's try it. And we're really hoping that we hit this magic number. And 7 times 9 is 63. And we make 13, 21, 22, 35, 37. Yay, we've got it. This is 27. 7 times 5,319 does indeed make 37,233. So that was a really big question. But how many months will it take him? 27 months. It will take over 2 years, 27 months, for him to pay off that amount. So before your exam, you can take a look at the cumulative review in the workbook. And best wishes on your exam. Practice what you need to, and good luck.